Hello everyone, and thanks for joining me. In this video, we're going to talk about annual worth analysis. And the idea is to evaluate investments based on their annual worth, comparing alternatives also based on their equivalent A, or annual worth. And in order to achieve that, we are trying to calculate equivalent uniform annual worth. And annual worth is the difference between equivalent uniform annual benefits and cost. So that's why EUAW is equal to EUAB, standing for benefit, minus EUAC. And in this formula, both B and C are positive values, and we're taking the difference between them. And if you happen to end up a project with EUAW of positive, which means benefit is larger than cost, that's a good thing. So let's take a look at one example. Here it says a machine will cost $30,000 to purchase. So we have this $30,000 negative cash flow at year 0. Annual operating and maintenance costs, O&M, will be $2,000. So that's why you have these $2,000 over 5 years negative cash flows. The machine will save $10,000 per year in labor costs. So that's a positive impact that this machine will bring to the project. So you will add $10,000 positive cash flows over 5 years. And the salvage value of the machine after 5 years will be $7,000. That's why you have $7,000 positive cash flow in year 5. And we would like to calculate the machine's equivalent uniform annual worth, EUAW, for an interest rate of 10%. So the idea is converting this cash flow to a uniform cash flow, essentially, and calculate the A. In order to do that, we're going to treat the positive cash flows separately from negative cash flows and converting both of them to an equivalent A and taking the difference. So here we're calculating equivalent uniform annual cost, the negative cash flows, and that is $30,000 times A given P, 10% over 5 years. And A given P turns this one-time present value into an annual value for us, plus 2,000. And 2,000 is already in terms of annual value. So that will give us about $10,000 annual cost, uniform annual cost. And the benefits, same way, $10,000 is already in terms of annual, and $7,000 is a future value. So we're using this factor of A given F to convert it to an annual value, and then we're adding them up, and it's about $11,000 annual benefit. And the difference is about $1,200, and that is the equivalent uniform annual worth. So at this point, you would say, okay, this project will bring about $1,200 per year. So when you have a single alternative and you want to evaluate that, if the EUAW, the annual worth, is positive, we recommend the alternative. And if you have multiple alternatives, you choose the one with the largest annual worth, or if everything is cost, with the smallest annual cost. And tracking revenues and costs on a yearly basis is very common in industry, because it makes sense to present the costs and revenues on a yearly basis. To say over the last 5 years, for example, the company made $2 million a year. And that's very relatable. So it's very common to use annual worth analysis. But I have to tell you that we have already talked about net present worth analysis in the previous chapter. But whatever method you use, annual worth analysis, present worth analysis, or even future worth analysis, where you're turning every one of these cash flows to a future value and comparing them, they should give you the same recommendation. If you're comparing multiple investment alternatives and using these methods, the result shouldn't be different using any of these methods. They're just different ways of approaching to solve the problem, but the ultimate result is going to be the same.